All right, class. So today what we're looking at in this lesson is greatest common factor. And we're going to be looking at greatest common factor as polynomials, okay? But before we go into our examples, let's look at some definition and some steps that we're going to take in order to find GCF. The first definition that we have is factor. A factor is a whole number that divides into another number evenly, leaving no remainders. So when we divide, we're making sure that we don't have any decimals. GCF. GCF is the largest positive integer that divides two or more numbers evenly. So we're going to be looking at coefficients, and with coefficients, we're going to have more than one number sometimes. And when we do those, what we're looking at is a number that can divide into those, and it has to be the biggest number out of the list that we can find. Okay. Prime. Prime is a number that can only be divided by itself in one. Okay, so that will make a number prime. All right. We have to remember that factoring is like undoing multiplication or using distributive property backwards. All right. So that's just something to keep in mind. Now, the steps that we're going to take when we're solving, the first thing we're going to do is we got to identify the GCF of the coefficient. Now, we remember that the coefficients are the numbers in front of a variable. So we're going to find those GCFs first. It says that the highest number that goes into each of the numbers. So if we look at a problem and there's all the numbers that are there, what we find for a GCF has to be able to be divided into all of the numbers in the problem. Okay. It cannot just be one. It can't be just two of them. It has to go divide into all of them. But we also got to pay attention that we need the highest. All right. Step two, we're going to identify the GCF of the variables. Now, with variables, we're going to be looking at the smallest power of each of the variables or expressions. Okay. The word power is another word for exponents. So we're going to be looking for the smallest exponent in the expression. All right. Now, from there, step three says we're going to factor out all the GCFs from the polynomial, meaning factor means divide out. We're going to divide out all the GCFs from the polynomial or the expression that they gave us. And then we're going to simplify if necessary. So those are the steps that we're going to follow going through each one of our examples. So let's move to example one. All right, so let's look at example one. And example one says factor 12x raised to the 6th power plus 18x raised to the 5th. Now, in order to factor, we're going to follow the steps. Step one says that we got to find the GCFs of the coefficients first. Now, if we remember that the coefficients are the numbers that are in front of the variables. So the numbers that we have out front of our variables is a 12 and an 18. So we're going to find the GCF of those. So let's write 12 and 18. Now, to find the greatest common factor, we have to know the numbers that multiply to get 12. So we think we can go through our times tables, but I'm going to use Desmos today. What we're going to do is take 12 and we're going to divide it by 1. So that's going to be 1 times 12. Try 2, that'll give me 2 times 6. Try 3, that'll give me 3 times 4. And let's try 4. Now, if we do 4, you notice that it's actually repeating 3 and 4. It's just backwards. So when we notice that the numbers are starting to repeat, we can stop. So those are all the numbers that I can use that multiply to give me 12. Now we got to do 18. So if we go to 18, we hit divide by 1. That'd be 1 times 18. We do 2. That'll be 2 times 9. We do 3. That'd be 3 times 6. We do 4. If you notice, 4 doesn't go into 18 evenly, so we can't use that one. We do 5. 5 don't either. Try 6, and that gave me a repeating one, just like 3 times 6. 6 times 3 is the same, so we can stop there. Now, once we get those, what we're looking for is the greatest number that they both have in common. So you look at all your lists, and you find the greatest number that they share, and in this one, I see 6 is the greatest number that both of them share. Now, because that is the greatest number they share, we're going to write that down under our GCF. After we get the number, the coefficient taken care of, we look at the variables. Now, the variables that we have in this one is just an x. So we go ahead and write an x right beside the 6. Now we're going to look at the smallest exponent in that expression or problem. Okay, the smallest exponent is what we can take out for that letter or that variable. So the smallest exponent is 5. So I can factor out 5 x's from everything. Okay, now that is taken care of, we know what our GCF is. We can divide everything out from each term. So the first one we have is 12x to the 6th power. We're going to divide that by 6 to the 5th power. Okay, 12 divided by 6 is 2. And we can take 5 x's from the 6 x's, that leaves us just x. All right, and then we can do the 18. We're going to divide that by 6x to the 5th. 18 divided by 6 is 3. We're going to keep the plus sign, just 3. And if I got 5, take away 5, which that means all the x's go away. That means that's that part. Now that's going to be what's remaining. What we took out was the 6x to the 5th. We'll put that out front. Now with that being out front, that is our final answer for this problem. All right, so for example 2, they want us to factor 16x to the 4th plus 24x to the 3rd plus 8x squared. Now, in order to factor this, it's the same steps. We're going to first find the factors of the coefficients, which is the number in front of the variable. And then we're going to look at the variables themselves and find their GCF. Okay, so let's go ahead and do our numbers. So the numbers that we have out front this time are 16, 24, and 8. So we got to find what numbers we can use to multiply to get these numbers that we have for our coefficients. So let's start with 16. Now that I have all my factors that multiply to give me the numbers, I can find which one is the greatest one for all the lists together. So if we look at our list, we're finding what number shows up in all 3 lists, but it has to be the biggest number. So if you go through, we notice that 1 repeats for all 3. We notice that 2 repeats. We see 4 repeats in all 3. Okay, we see 8 repeats in all 3. And that's the only thing that repeats for all 3. Now, out of the ones that repeat, the greatest is 8. So that is our greatest common factor of all 3 numbers. Okay, so starting with our GCF, we have 8. Now the letters we have are just x. Okay, so I'm gonna go ahead and put one of the x's down, but we're gonna look through all of our variables and see which one has the smallest exponent. The smallest exponent we have is 2. So that means I can factor out x squared from, or take away x squared from each one of those. Okay, so now let's divide out. First thing we're going to do is 16x4 divided by 8x squared. So 16 divided by 8 is 2. And then I can take 2 x's from the 4, so that's going to give me x squared left. Now we have 24x to the 3rd. We're going to divide that by 8, x squared. 24 divided by 8 was 3. And we can take 2 x's from the top, so that's going to leave me with just 1 x, because that's 3 minus 2. And then the last one was 8x divided by 8x. 8 divided by 8 is 1. So we got 1, and then the x's go away because we took both of them away. So that's what we get when we divide out, and then we'll take our GCF and put it out front. And that will give us our answer for example 2. And that's what we get when we factor out the 8x or factor out our GCF. For example 3, which is our last example, we got to factor 30x to the 4th, y to the 3rd, plus 18x to the 6th, y squared, plus 42x squared, y to the 3rd power. Now, when we factor that, remember we start with the coefficients, which is the number out front of each variable, and then we do the actual variables themselves. So when we do that, the numbers that we got to find the GCF for first are 30, 18, and 42. So if we do 30, the number that they share that is in common for all three for GCF is 6. That's the biggest number that they both share in common. So now since we know that, we can start our GCF with 6. Now we look at the problem. The problem has two variables in it. It has an x and a y. So I'm gonna go ahead and put my x and my y down beside my GCF. Now once I do that, look at my x's to see which one has the smallest exponent. The smallest exponent for x is 2. So I'm gonna put a 2 with the x. And then I look at my y's. The smallest exponent is also 2. So my GCF will be 6x squared y2. Now I'm gonna take that GCF and divide everything by that. Okay, so the first one will be 30 x to the fourth y3 divided by 6x squared y squared. That one will give me 30 divided by 6, which is 5. 4, or x to the fourth minus x to the second will give me x squared again. 3 minus 2 will give me y. Now I do the next one, which is 18. X to the 6, y2 divided by 6x squared, y2. 18 divided by 6 is 3. 6 minus 2 is 4, so it'll be x to the fourth. 2 minus 2 means the y go away because that's 0. Now I do my next one, which is the 42. X squared, y to the third, divided by 6x squared, y2. 42 divided by 6 was 7. X squared and divided by x squared, basically the x's go away because when you subtract, they cancel each other out. Now 3 minus 2 will give me y. So that's what's left there. That's a remainder. Now I can take my GCF and put it out front. And this will be my answer. So the answer for that one is here. Now we take what we have and what we just gained about finding GCF, and we can put it into practice. If you have any questions, don't hesitate to ask.